You are correct in your understanding of the term buck in electrical terminology. To buck means to apply a voltage to another voltage in opposite polarity to reduce it. In the circuit you provided, the autotransformer is wired to boost the voltage, not to buck it. The exhibit 210.18 top left of page 80 is incorrect. The correct way to wire the autotransformer to buck the voltage would be to reverse the polarity of the zone and X4 windings. With this wiring, the voltage between terminals 1 and 4 will be reduced. The autotransformer, in its basic form, is a single winding transformer that uses a portion of the same winding for both the primary and secondary circuits. This design differs from an isolation transformer, which has separate primary and secondary windings providing electrical isolation. The autotransformer's configuration allows for a smaller size, lighter weight, and often a higher efficiency compared to a traditional isolation transformer for similar voltage transformation ratios. Autotransformers are commonly used where electrical isolation is not a requirement and voltage adjustments are needed. Understanding the winding connections is crucial for proper operation. The high voltage side, typically labeled H, receives the input voltage. The low voltage side, labeled X, provides the output voltage. Taps on the winding allow for varying the turns ratio, enabling different voltage levels. The common connection between the high and low voltage sides is key to its operation. When connecting an autotransformer to boost voltage, the low voltage winding adds to the high voltage winding. This is achieved by connecting the Hone terminal to the X2 terminal and applying the input voltage across Hone and H2. The output voltage is then taken from Zone and H2, effectively increasing the voltage. Conversely, to buck or reduce voltage, the low voltage winding subtracts from the high voltage winding. In this configuration, the Hone terminal is connected to the Zone terminal and the input voltage is applied across Hone and H2. The output voltage is then taken from X2 and H2, resulting in a low voltage. The crucial difference between boosting and bucking lies in which terminals are connected together. Connecting Hone to X2 boosts the voltage, while connecting Hone to Zone bucks the voltage. Reversing the polarity of the low voltage winding, as you mentioned, is indeed the correct way to achieve bucking. This ensures that the induced voltage in the low voltage winding opposes the voltage in the high voltage winding, resulting in a voltage reduction. The bottom exhibit you referenced is correct in illustrating this principle. It demonstrates how connecting terminals 1 and 4 between H and X boosts the voltage, while connecting terminals 1 and 1 between H and X bucks the voltage. Therefore, the mistake in the top left exhibit lies in its incorrect representation of the bucking configuration. The connections shown do not effectively subtract the voltage from the primary side, rendering it ineffective for bucking purposes. The definition of bucking specifically refers to applying a voltage in opposition to reduce the overall voltage. The described scenario with the batteries exemplifies this principle. Inserting a 1.5-volt battery in reverse polarity within a 6-volt circuit would indeed reduce the voltage to 4.5 volts, illustrating the concept of bucking. The error in the exhibit then lies in its misapplication of this definition within the context of the autotransformer connections. The exhibit incorrectly portrays a boosting configuration as a bucking configuration, failing to accurately represent the necessary winding connections for voltage reduction.